Good morning, dear students. I am Amrita, your chemistry lecturer. In the previous session, we learned group detection of basic radicals by using specific group reagent. I hope the concept is clear to all. So today in this session, we will discuss analysis of basic radicals. Okay. So first we will discuss analysis of first group basic radicals. So let us perform the experiment. So for this experiment, you have to take a test tube. So for that test tube, take a small amount of salt mixture. Now I will take a salt mixture, add that salt mixture to a test tube, then add distilled water. Slowly you have to add distilled water. Shake the test tube well so that the salt is completely dissolved. Okay. So you will get a clear transparent solution. Okay, this is the first part. Next one is take another test tube. I will take another test tube. So for that, take the same salt mixture. By using a spatula, add salt mixture to a test tube. Then in this case, you can add tap water. So observe the difference. So here I will add tap water. What happens means the salt mixture is not completely dissolved in a tap water, whereas in distilled water the salt mixture is completely dissolved. So that one is taken as a original solution. By using original solution, you can perform the experiment. So here first you have to analyze the first group basic radicals. For that I will take the original solution, then add first group reagent. So for the determination of first group basic radical, I will use dilute hydrochloric acid as a group reagent. By using a dropper, add small amount of dilute hydrochloric acid. Observe carefully. By using a dropper, add small amount of dilute hydrochloric acid to a original solution. Observe the changes. You can notice there is a formation of white precipitate. This takes place in the test tube. Okay, clearly observe there is a formation of white precipitate. This takes place in the test tube. So this will indicate the presence of lead ion. If you get white precipitate, this is confirms the presence of lead ion in the salt mixture. Okay, so filter the precipitate by using another test tube. For filtration, you have to take a filter paper and a test tube. So here you have to do the filtration. Transfer the precipitate to a funnel. Then you will recollect the precipitate in the test tube. Okay. Observe carefully. Recollect the precipitate. To that precipitate, you can add distilled water. Small amount of distilled water you can add to a test tube. Shake well. Then After adding distilled water, warm it by using a burner. Warm it so that the precipitate is completely dissolved. The white precipitate is completely dissolved. Observe the changes carefully. So the white precipitate is started to dissolving. Then the dissolved precipitate is divided into two parts. Okay. By using a two test tube, you can dissolve the precipitate into two parts. So this is the dissolved precipitate. You will observe the dissolved precipitate in a test tube. Then you can transfer the dissolved precipitate into two different test tube. Then name it as a test tube A and test tube B. Test tube A and test tube B. So in test tube A already contain dissolved precipitate. So for that dissolved precipitate, you can add potassium iodide solution. Observe carefully. Take a potassium iodide solution. By using dropper, add small amount of potassium iodide to a dissolved precipitate dropwise. Observe the changes. So you will get yellow precipitate. Observe carefully. There is a formation of yellow precipitate. It takes place in the test tube. So it will confirms the presence of lead ion in the salt mixture. This is the first case. And in second case, take test tube B. It contains dissolved precipitate. And to that precipitate, you can add potassium chromate. So little bit potassium chromate solution is added to a test tube. Then you can notice here also there is a formation of yellow precipitate. Okay. So this confirms the presence of lead ion. So this is about analysis of first group basic radicals. Okay. Thanks for watching.